Hello everyone, my name is Abdisamad Hassan. Today I will talk about journaling and log structure file system and how they help the operating system and keep data safe and consistent, especially after crash and failure. And we need to journal everything about consistency and saving your data and the structure of your file. And today, and also we're gonna talk about what's the file system and the high level of role of file system and why it's matter. The file system is storing and resources reliability. Uh, it's make data and it's make folders like safe. Like he basically organize your disk. You decide your file storage and how folders are structured and keep metadata like size and out. You can increase, you can decrease, you doing something like that. In firstly, there are some background on what's the file system and it is why its reliability is important. Then I will explain the file journaling file system. After that, we explain log structure files. Next, we will compare terms of recovery and data safety performance, especially SSD. Also, we mention the real data example like Extra and NileF S2. Finally, we talk about also the challenges and futures idea shortly. The second one, why file system reliability is matter. Like, what's the typical of the if we see the typical of file system is like power loss was unexpected. Someone the battery will be lost and data will not be saved. That's why it is file system is a matter. And also system crash. He said a kernel panic or unexpected operating shutdown during critical critical file operation. Also, the problem will be disk error. Typically, disk or SSD failure, including bad sector and control manufacturing. Sometimes, if you are using your computer and maybe you take off your computer and the SSD will be move the position he was before. That will be why this sometimes will be mistake or like it's a typical failure scenario. And what's our goals? We need to be reliable file system, constancy, boost the report. After unexpected reset, the file system international structure must be coherent and maintainable. We must minimize also the second point will be minimal data loss. At most only few recently written should be lost. If we write a lot of data, if we lost the most all, there will be a big problem. To ensure that we must to use minimum data loss. يعني we
Hello, doctor. My friend, he finished the first four slides of this presentation. So I'm gonna start here. Failure model of and crash consistency. The failure model is the system can crash any point during sequence of writing operation leading to an inconsistency state. So the disk may contain a mix of old and new data reflecting partially completed writings. So let's break it down. Uh, for example, the old data it was hello world. The new data it is hello Mohamed. So it became mixed because of crash. When it became mixed, uh, the data, the result we waiting is they gonna became something we can't understand because of mixed. So crash consistency is second one. The crash consistency, it is three parties. Integrity, which is file system metadata, direction, node tables must never be corrupted. Data rollback, user data may roll back to an order but failed and consistency version rather than being partially updated or corrupted. So gonna save us the corrupted files. So when we have a crash consistency, our file is it will not be corrupted. So this is traditional update in place. How it work? Directly operated data blocks and metadata in their original disk location relies on file system check anti-utilities and carefully ordered right operation. For example, two pictures, we're gonna switch two pictures in the same location. It became mixed, so because of correct, but the file system check is gonna save that two of pictures make good. Okay, journal and file system high level idea. This key idea, all changes are first recorded in a journal log on detected area of the disk. Only after transactions safely journal are actually updated applied main file structure. What's the benefit? Fast recovery, strong metadata protection. So fast recovery, instead of taking long time, hours, it gonna take maybe seconds or it can take minutes. Okay, journaling modis. It is data plus metadata, strong safety, most expensive. Order mode, metadata journal, data first. So this is uh, the parties of that metadata and data journaling modes. So this one is fast, but it's risky. This the recovery takes maybe seconds, but it's not guaranteed. It's too risky. So metadata ordering is something we can't take seriously. This one, data is first, but journaling is the next one. So that is my last part of presentation. Have a good night. I'm gonna stop the recording. Okay, في
Hello teacher, my name is Sadik. I will start in this slide. So slide 1, journaling workflow EX3, EX4. So on this slide, I will explain how journaling works in EX3 and EX4. So the process begins when in the application writes data instead of writing directly to the file system. The changes are first written into the journal. This ensures that if something goes wrong, we have to record it plan. After the journal records the changes, a commit entry is created to confirm and that everything is consistent. Then the committed changes safely apply to the main file system. Once you completed, the journal entry is cleared to make space for the new transactions. Journaling acts like safety net book, write it first and apply later, reducing corruption risk. And in slide 2, and recovery journaling versus LFS. So here I compare how both systems recover after crash. Journaling uses journal replay. The system scans the journal and reapplies the incomplete and committed changes, focusing them mainly on the metadata
This makes recovery fast. So LFS or long structured file system and rely on checkpoints. After crashes, LFS loads the last checkpoint and scans recent logs and segments to reboot the state. Journaling replaces operations quickly, where LFS reboots the file system using checkpoints and log scanning. And, and in slide 3, and we talk the performance characteristics and trade-offs. So next, the performance differences journaling system to have low and rate amplification because mostly metadata is journaled. They handle random and sequential rates well and with minimal cleaning overhead, making them stable and both HDD and SSDs. So LFS, on the other hand, rates everything as low, which can cause higher rate and amplification. And it excels in the second rate is provides great performance for HDDs. However, the segment clear introduces overhead and can reduce SSD lifespan. So in short, journaling equal stability and low overhead. And LFS high performance but more maintenance. In the last slide, uh, low structure file system data. So finally, the concept of LFS treats the entire disk and open it only log. So all new data is straight into the end of the log and all database become indeed and later reclaimed. So this defined provides strong benefits and sexual sensualis rate maximum throughput and crash recovery becomes simple because only the last checkpoint and reset log segment are needed. So overall, LFS boosts rate performance and simplifies recovery, but requires background clearing manage each segment. Thank you.